Hello and welcome. I want to start with a question that I'm confident will resonate with everyone. Have you ever opened a file in a project and just stared at it, completely lost? The code works, you're told, but you have no idea how or why. It's a mess of integers, strings, and long, confusing methods. You have to spend hours, sometimes days, translating this machine friendly code into a human understandable concept before you can even think about making a change. This experience is incredibly common, and it's a sign that the code has lost its connection to the design it was meant to represent. The code may function perfectly from the computer's perspective, but from a human perspective, it becomes an archaeological artifact that requires excavation and translation to understand. Today, we're going to talk about the antidote to this problem: design reflective code. We learn how to write code that tells a story, code that acts as a living blueprint for your system. By the end of this lesson, you'll be able to define what design reflective code is, apply three core principles to achieve it, and transform brittle, confusing code into clear, extensible, and maintainable model of your problem domain. The fundamental insight we'll explore is this: your source code should be a single, authoritative representation of your system's design, not a separate document, not a diagram that gets out of date, but the code itself. When this alignment exists, extraordinary things happen to your development process. So, what exactly is design reflective code? Simply put, it's code that mirrors the concept of the problem it's solving. The goal is for the source code to be the single, unambiguous source of truth for the system's design. This isn't just an academic exercise or a nice to have luxury. It has powerful compounding benefits that transform how you develop software. Let me walk you through these benefits with concrete examples so that you can see the practical impact. The first benefit is a dramatic reduction in the cognitive load. The first major benefit is that design reflective code dramatically reduces cognitive load. Human working memory is limited. We can only juggle about 7 pieces of information at once. When code doesn't reflect the domain, our brains are constantly doing translation work instead of problem solving. Let me show you what I mean with a limiting example. Imagine you're reviewing code and you encounter this line. To understand this single line of code, your brain has to ask a series of questions. What exactly does the check method do? What is stored in the request history map? What does 100 represent? Is it 100 requests? 100 what exactly? Is it per minute, per hour, per day? What's the relationship between the user ID string and the map? Your brain is doing translation work, burning mental energy to decode the implementation details before you can even begin to understand the business logic. Now, compare that experience to reading this line. This version speaks for itself. The intent is immediately clear. We are checking if a request is allowed for a specific identifier. The underlying policy, whether it's a token bucket, a sliding window, or fixed window algorithm, and how it's tracked are hidden away, letting us focus on the what, not the how. Your brain can immediately understand the business operation without any translation overhead. This mental clarity is the first major win, and it compounds throughout your code base. When every method, every class, every interface speaks the language of your problem domain, the entire system becomes dramatically easier to understand and work with. The second benefit is the ability to make surgical low risk changes. The second transformative benefit is that design reflective code enables surgical low risk changes. When your code structure reflects the problem structure, a change in a business rule maps to a change in exactly one place in your code base. You know precisely where to make the change and can be confident that it won't have unexpected side effects. Let me illustrate this with a payment processing example. Consider a traditional payment processing method that uses a switch statement to handle different payment types. Now, imagine your product manager comes to you and says, we need to add cryptocurrency payment support. With this approach, you have to perform what I call an open heart surgery on this central switch statement. You're modifying a critical method that handles all payment processing. It's risky because you could accidentally break the logic for credit cards while adding the crypto logic. Every line you touch increases the risk of introducing bugs into working functionality. But in a design reflective world, you'd have structured this differently. You'd have a payment method interface that encapsulates the concept of processing payments, and each payment type would be its own focused implementation. Now, when you need to add cryptocurrency support, the change becomes surgical. Notice what happened here. We added new code, but we didn't have to change any existing working code. The credit card logic, the PayPal logic, and payment processor core remain completely untouched. This is incredibly safe and scalable. You can add new payment methods with zero risk of breaking existing functionality. The third major benefit is that design reflective code provides what I call high leverage testing. Your tests can verify business requirements directly, expressed in the same domain language that stakeholders use. When a test fails, it tells you that a specific business rule is broken, not just that some arbitrary line of code is wrong. Now, in the traditional approach, tests often look like this. This test is focused on implementation details. It's checking that certain methods were called, that internal counters were incremented, and if this test fails, you know something broke, but you don't immediately know what business requirement was violated. Now, compare that to a design reflective code. This test reads like a business requirement. The test name tells you exactly what business behavior it's verifying. If this test fails, you immediately know that credit card payment processing is broken. The test speaks the language of the business, not the language of the implementation. This alignment between tests and business requirements creates a powerful feedback loop. When requirements change, you know exactly which tests need updating. When tests fail, you know exactly which business rules are violated. Your test suite becomes a living documentation that business stakeholders can actually understand.